Hello everyone, welcome to my YouTube channel Expert Engineer. Today we are going to learn some basic definitions that every mechanical engineer should know. So today we are going to learn engineering properties of materials. So the first property is elasticity. It is a property of a material by virtue of which deformation produced due to applied stress gets completely or partially disappear when the stresses are removed. Each body will more or less deform on application of load. The deformation will be elastic when the body recovers its original shape completely after removing the load. For each elastic body, a certain limit exists beyond which the material will hold a remaining deformation. This limit is called elastic limit. Some examples of elastic materials are steel and rubber. Steel is said to be more elastic than rubber. The next property is plasticity. It is the property of a material by virtue of which material undergo permanent change in shape without fracture. Plastic deformation will take place only after elastic limit has been exceeded. Next property is strength. The greatest stress resisted by a material without failure is called its strength. This failure is defined by a designer depending on which there may be different strength for a particular material such as yield strength, breaking strength, fracture strength, etc. Ductility. It is the property of a material by virtue of which material can undergo large deformation such as mild steel, copper, aluminum, etc. Through ductility, a metal sheet can be drawn into wires of a thin section. Ductility of material can be measured by the percentage elongation and the percentage reduction of area before and after rupture of a test specimen. Stiffness. It is the ability of a material to resist deformation under loading. Modulus of elasticity, tangent modulus are the measures of stiffness. The material which suffers less deformation under load has high degree of stiffness. The next property is malleability. The capacity of a material to withstand deformation under compression without rupture is called malleability. Malleable material possess a high degree of plasticity but not necessarily great strength. Forging and rolling operations in which metal is formed by hammering or rolling utilize malleability property. Gold is most malleable and lead is malleable next to gold. Malleability is differs from ductility because ductility is considered tensile property while malleability is considered compressive property. The next property is brittleness. It is the property of a material by virtue of which a material fails suddenly without undergoing any noticeable deformation. Brittleness is opposite to ductility. Therefore, non-ductile material is said to be brittle material. A brittle material does not yield and fails without giving notice in actual structure. Next property is hardness. The ability of a material to withstand scratching, wear, and abrasion or indentation by harder body is known as hardness. Diamond is the hardest known material. Hardness is an important property of cutting tool materials and of components which most resist wear. Hardness is mostly measured by determining the resistance to penetration by different methods such as Brinell, Rockwell, and Vickers hardness tests. So this is the specimen which is used to measure the hardness of a material. So there are different types of uh, indentation specimen used in this machine. So in Brinell hardness test, uh, circular indented is used. In Rockwell hardness test, spherical diamond tipped shaped cone is used. In Vickers hardness test, pyramid shaped diamond of angle 136° angle is used. In Noob hardness test, extended pyramid shaped diamond of tip 172° cross 130° angle is used. The next property is toughness. Toughness is the amount of energy that a material can absorb before it fractures. Area under stress strain curve represents toughness of that material. A ductile material with same strength as non-ductile material will require more energy for breaking and hence it is more tough. A ductile material with same strength as non-ductile material will require more energy for breaking and hence it is more tough. Charpy test and isode impact test are used to measure toughness. So this is a test specimen which is used to measure toughness of a material. So in isode impact test and Charpy impact test, the position of test specimen is different, which is shown in the figure. The next property is creep. When a member is subjected to a constant load over a long period of time, it undergoes a slow permanent deformation and it is termed as creep. It depends on temperature. Usually at elevated temperatures, creep is high. The next property is resilience. Strain energy stored by a body within elastic limit is called resilience. Resilience is the ability of a material to absorb energy when it is deformed elastically and release that energy upon unloading. So here in stress strain curve you can see so the area within the elastic limit is the energy absorbed by the material is called resilience. Roof resilience is defined as the maximum energy that can be absorbed up to the elastic limit without creating a permanent distortion. Materials that have high resilience are used for springs. The next property is a fatigue. A failure of a material caused under repeated loads or stresses is known as fatigue or fatigue failure. Fatigue fracture occur without any warning. They result in brittle fracture. An example of fatigue failure is shown in figure. Thanks for watching guys. Please don't forget to like and subscribe.